Welcome back to session 18 of GED Science Mastery. Good to see you. Forces explain why things start moving, stop, speed up, slow down, and turn. The GED tests a few clean ideas here: balanced versus unbalanced forces, Newton's three laws, and the formulas for speed and for force. Get comfortable with the little equation F equals ma, and you can handle both the concept questions and the calculation questions. Let's push forward. Here is the big idea. A force is simply a push or a pull. Now, when the forces on an object are balanced, meaning they cancel each other out, the object's motion does not change. It stays still or keeps moving exactly as it was. But when the forces are unbalanced, one side wins, the object speeds up, slows down, or changes direction. We call that change in motion acceleration. So balanced forces keep things steady. Unbalanced forces cause acceleration. Newton's first law is the law of inertia. It says an object at rest stays at rest, and an object that is moving keeps moving at a steady speed in a straight line, unless an unbalanced force acts on it. In other words, things naturally keep doing what they are already doing. This is why when a car suddenly stops, your body lurches forward. You were moving, so you keep moving until the seatbelt provides the force to stop you. More mass means more inertia, more resistance to any change in motion. Newton's second law is the workhorse formula: force equals mass times acceleration, written F equals ma. Rearranged, acceleration equals force divided by mass. Read what it tells you. For a given object, more force produces more acceleration. Push harder, speed up faster. And for the same force, more mass produces less acceleration. A heavier object is harder to get moving. This one little equation lets you calculate force, mass, or acceleration whenever you know the other two. Newton's third law says that for every action, there's an equal and opposite reaction. When a rocket pushes exhaust gases downward, the gases push the rocket upward with equal force. When a swimmer pushes water backward, the water pushes the swimmer forward. Forces always come in pairs. And one more essential formula: speed equals distance divided by time. A runner who covers 100 meters in 20 seconds is moving at 100 divided by 20, which is 5 meters per second. Let's read a real GED-style experiment. A student pushed the same 5-kilogram cart with different net forces and measured how quickly it sped up, its acceleration. Look at the bars, which show acceleration. With a 10 Newton force, the cart accelerated at 2 meters per second squared. With 20 newtons, 4. With 30 newtons, 6. Notice the pattern climbing steadily. Every time the force goes up, the acceleration goes up right along with it, in perfect step. Let's find the pattern and make a prediction. What relationship do the data show, and what acceleration would 40 newtons produce? Read. With a 5-kilogram mass, 10 newtons gave 2, 20 gave 4, 30 gave 6. Choose. Each acceleration is the force divided by the mass. 10 over 5 is 2, 20 over 5 is 4, 30 over 5 is 6. It fits F equals ma perfectly. So for 40 newtons, acceleration is 40 divided by 5, which is 8 meters per second squared. Check. Doubling the force doubles the acceleration. They are directly proportional, exactly as F equals ma predicts. Let's ground this in daily life. Friction is a force that opposes motion between surfaces. It is why a sliding book eventually stops, and why we can walk without slipping. Gravity is the force that pulls masses together. On Earth, it pulls everything downward, giving objects weight. And inertia, from the first law, is why a still object needs a push to get going, and a moving object needs a force to stop. When you read a motion problem, quickly ask which forces are acting, and are they balanced or unbalanced? Let's lock in the traps. 1. Thinking a moving object needs constant force to keep going. No, by the first law, it keeps moving on its own. Force is only needed to change motion. 2. Thinking heavier objects accelerate more. No, for the same force, more mass means less acceleration. 3. Thinking balanced forces mean no forces. No, forces can be present but cancel to 0. 4. Mixing up speed and velocity. Velocity also includes direction. The recap. Balanced forces keep motion steady. Unbalanced forces accelerate. And F equals ma ties it together. Excellent work today. You can now tell balanced from unbalanced forces, state Newton's 3 laws, and use F equals ma and speed equals distance over time. Your practice for this session is the 10 questions attached to this lesson. Answer them from memory, and for any force problem, write F equals ma first, then plug in your numbers. To read the full lesson notes and practice more GED science questions, visit the course page at www.bridgetoexam.com. I am proud of your progress. I will see you in session 19, where we explore work, machines, power, and efficiency. Keep going. You are doing great.